All right, let's get started. Let's kick off the practitioner track with Kat Cosgrove, who will be joined by engineers Kyle Dixler and Aaron Friel, who actually built the Java and YAML support, to show you some cool demos and dig in even deeper.
Hey, y'all. Thank you for joining us at Pulumi Up. I hope you enjoyed the opening keynote. We had some pretty exciting announcements, but we didn't have quite enough time within the keynote to do justice to the two things we were most excited about: the introduction of support for YAML and support for Java. I am here to help with that. My name is Kat Cosgrove, staff developer advocate here at Pulumi. I will be your guide, and I'm joined by two colleagues today, Aaron Friel and Kyle Dixler. We'll be giving you an overview of both features, including demos and some ideal use cases. So let's dive in. For the ops folks in the crowd, we're excited to introduce YAML support for Pulumi. This is designed with simplicity in mind, and it's ideal for smaller and less complex deployments. If you're coming from another environment that uses YAML, this is going to look very familiar to you. If you have experience with Kubernetes deployments, this is going to look nearly identical. YAML for Pulumi has access to all core features of Pulumi. It's also able to consume outputs from other Pulumi programs and can even use components written in other supported languages. So it's pretty flexible. Now, because it is YAML, you don't have access to things like loops, but if you do reach a point where the expressivity of a programming language is required, a Pulumi program written in YAML can be quickly and easily converted to the supported programming language of your choice using the Pulumi CLI. So what does that look like? To help, I've got my coworker Aaron Friel here to show off some possible applications of Pulumi for YAML. So I will now toss it over to him.
Yeah, thank you, Kat, for introducing me. I'm here to walk through a few quick demos of the new Pulumi YAML language support. We're going to walk through demoing, standing up a S3 static website. You can probably already see that on the screen. We're going to stand up an EKS cluster. We're going to deploy some things to it, and then we're going to do something a little more magical. We're going to convert that YAML into Python and TypeScript. To start out with, I want to talk through this S3 website Pulumi program. So if you're familiar with Pulumi, you've probably seen the pulumi.yaml project file before. We've extended it with a few new things. I'm going to go through these sort of top to bottom here and highlight. We are setting the runtime to YAML. That's going to use our language host, and that will ship with the Pulumi CLI built in. You're going to be able to declare resources in your pulumi.yaml. We're declaring a myBucket resource, and we're using our API docs to get this type string here. The first part of the type string is the Pulumi package that's providing it. And some packages will use a hierarchical scheme. AWS has a wide variety of resources. So we're going to be looking under the S3:bucket for this resource. And we're going to be declaring some properties. We support all of the rich properties that we have in our API docs for YAML. So we're going to give this an explicit name. I've already practiced standing this up. We're going to give this a website declaration. So we're going to have it serve a static website. And then we're also going to give it an index document to be able to store in that. So we're going to create a bucket object resource, declare properties on that bucket. And this is where because we are controlling the YAML execution, if you will, we can do things like variable interpolation. So we can use a $ and curly brackets to refer back to this resource. You can do this in either order. I could put the index above myBucket, and what we'll do is when we read this YAML document, we're going to reorder anything in order to avoid cycles, for one thing, and detect those and provide an error, but also to ensure that resources are created in the appropriate order, right? The bucket has to exist before we can create an object in it. We're going to insert this object as an index.html, and we're going to then put a asset as the source. So we do support our assets and archives. We have 6 flavors of those, from file assets to nested sort of like tar file sort of assets where you can specify multiple files within a single asset. We're just using a single static string here. We're going to serve this malformed HTML5 document that just has a heading saying hello with love from Pulumi. We're going to set that to public read, of course, and then we're going to set the content type so that we can actually pull that down with curl and get a nice output. Lastly, in order to actually get that output into my CLI, we're going to declare some outputs. We're going to set the bucket endpoint output to, again, we're going to interpolate this variable reference using the $ curly brackets, refer to my bucket, refer to the website endpoint output on that bucket. So just do a quick demo of what that looks like. Let's go back here. And I'm going to do a Plumi stack init dev. And I'm going to do a Plumi config set. Need to set a region and Plumi up. So again, this is baked into the Plumi CLI as of today. And my mistake there. Let's select yes on Plumi up. And you'll see that this creates a S3 bucket, puts that object there, and makes that accessible via the S3 URL. And I'm just going to give that about 5 seconds here to ensure that I don't hit a negative DNS cache when I try to curl that. So I'm going to do a Plumi stack output bucket endpoint. And I see that I have successfully pushed this index.html into this bucket. So I can use Plumi YAML to deploy static websites with sort of arbitrary complexity there. This is a fairly straightforward example, though. And we think that some of our customers are going to want to use things like our component resources, such as our EKS provider, where they will bake in sort of best practices or good defaults. And I want to show an example of what that looks like here with an EKS example. So starting out, we have an additional key here. We have a variables declaration. In this variables, we are declaring 2 variables. And if you're familiar with deploying to AWS, you often need to do things like get the default VPC ID or get the list of subnets within a VPC. Those would be considered functions in our API docs, and we do support those in YAML. This is what one of those looks like. It's a function invoke. Anywhere we support an expression in our syntax, we support replacing that expression with just an object. So this is an object containing a single key, function invoke. And you can then specify, again, from our API docs, sorry. Then you can specify from our API docs the type of this function or the name of this function, any arguments that it requires. And optionally, if you have a single return key that you would like, you can ask for just that single ID, for example, key, or you could get back an object and store that in the variable and use, again, our interpolation syntax to be able to retrieve properties off of that. Similar thing with the subnet IDs, we're going to be invoking the easy2 get subnet IDs function, and we're going to be passing it the VPC ID that we previously acquired. And then I think this is the really magical part here, is this entire cluster declaration is only 9 lines of code using our EKS provider, specifying EKS :cluster, specifying the VPC and subnet IDs that we declared earlier, and declaring a fairly small size cluster for our use case here with just 2 instances, T2 medium. And then for us to be able to actually operate on this cluster, we're going to pull out the kubeconfig that an ops or app team user might need to access that cluster. Now I'm going to spare folks having to go through watching an entire EKS cluster go up, but I will show what that looks like in terms of a preview experience before we move into a sort of a pre-baked cluster to deploy some resources on top of it. So you can see here, even though I specified only a single EKS cluster resource, that component contains a wealth of other things that are required in order to securely and correctly deploy EKS into an Amazon account. So I won't go over all of those sub-resources, but this is, I think, the power of packaging up component resources in our registry and we hope to expand that in the future. Lastly, for our YAML program demos, I'm going to take that EKS cluster and demonstrate how we can use that cluster declaration to deploy some Kubernetes resources onto the cluster in the same YAML program. So obtaining some of the same levels of sequencing and complexity that you can get in one of our other supported languages without having to buy into all of the complexity of, well, having to run a runtime or compile a program for those other languages. So I'm adding a few new things into this document. First, we have a configuration key. This is equivalent to, in our other languages, being able to say the config.get Boolean, get string. This is in case you have a default value that you want to provide for referencing config. We can specify a default here, and if then a user were to override that, and I'm going to switch over to the stat config, I could set image name to anything I chose here, and that would then override the config on a per stack basis for that project. So I'm going to stick with, though, my default of just a simple web server image that I've pushed up. And I'm going to go over some of the new parts of this document. So I've taken the existing EKS cluster that we just previously looked at, and I've highlighted using my editor some of the new changes here. So first, I've added a new variable, which is not a string or Boolean, but it's actually a map. It's a YAML or JSON-esque map, and it's defining a key app, and it's defining a key app with a value of Nginx demo. And that's just to avoid some repetition later on in the document. For folks who are familiar with Kubernetes, you often have to provide this labels property in multiple places. This just simplifies that. So how do we deploy onto a cluster waiting for that previously defined EKS cluster to spin up? Well, we start by deploying a provider resource. So this is going to then provide the configuration for future resources that we want to deploy into a particular Kubernetes provider. And the flexibility this offers is you could potentially have multiple, and the flexibility that this offers is that you could potentially have multiple Kubernetes providers in the same Pulumi program and deploy into multiple clusters. One resource into the first cluster, one resource into the second, and coordinate more complex deployments. In our case, we've declared a single K8s provider resource. We're going to pass in that kubeconfig that we had shown earlier as an output. We're going to deploy a demo namespace, and we're taking advantage of Pulumi's automatic naming. So when we deploy this demo namespace, Pulumi is going to generate a suffix of demo dash, and then it's going to generate some base64-esque suffix so that we don't conflict with any other resources deployed in the cluster. So all we have to provide is that provider option. The next two resources here should be extremely familiar for Kubernetes professionals. We've got a apps v1 deployment, and the content of this resource, the properties, is almost verbatim what you would see via kubectl get outputting to YAML. The only difference being that we have these app labels, as I mentioned earlier, and the ability to then interpolate in, for example, what that auto-generated namespace name is going to be. So lastly, as well, we have that image name pulled in from our config so that we can have a different image in each environment that we want to deploy to for each stack. We declare a service. Again, very, very similar to what a Kubernetes get service output would look like, just with these interpolated in variables. And we have an output of a host name, again, pulling off some output that would and we have an output of a host name that depends upon the the status of the load balancer having completed. So we will correctly await for that service to deploy and for an Elastic Load Balancer hostname to be assigned to it in order to be able to provide a useful hostname for the user to use immediately after the stack is deployed. All right, and now let's look at what it looks like to Pulumi up this cluster and the Kubernetes resources into it. So we're starting out with an EKS cluster that I previously deployed. So we should only see the provider, namespace, deployment, and service to access that deployment spin up in this preview. And that's indeed what we see. Let me make the terminal a little larger. You can see the whole plan here. And the host name is an output because we don't necessarily know what the Elastic Load Balancer is going to assign to that service. We're going to have to await it after deployment. So let's watch that happen here. This should be pretty quick. Kubernetes is a little faster to deploy than EKS. And then we're going to get that Elastic Load Balancer host name as an output. So you can see the deployment is finished initializing. We're waiting for that service to acquire an internal and an external IP. And now the Elastic Load Balancer has assigned a hostname to it. Excellent. We've waited a second for that hostname to be available. We're now going to request it. And we can see that we've pushed up this Nginx Docker image with a very simple web page available on ELB. So that's how you can structure Pulumi YAML projects from simple to fairly complex. But there may be some cases where you need to exit out of the YAML environment and go to Python or a TypeScript or any of our other supported languages. And we do want to enable our cloud engineers to do so when they reach that point where they need to reach for a loop or they need to reach for some more complexity or an external library. So I'm going to go back to that first S3 example to highlight our last, and I think the most exciting feature of the YAML launch. So we are introducing a what we call Pulumi Convert. We're going to be able to convert from a source to a destination language and project, starting with our YAML language support. So Pulumi Convert, I'm going to convert this S3 website example. So again, this is just the static website deployed to S3. I'm going to convert that to Python. I'm going to write that to the as Python directory. And while it's experimental, I've got these nice little hearts displaying, and you're going to see it spinning up a Python virtual environment, installing the necessary dependencies. And shortly, we're going to see that it's going to tell us that we can just cd into that directory and Pulumi up. And we should have our YAML program now converted to Python with full fidelity. All right, so it says that I can change directory. Do that. It says that I can run Pulumi up. And we should see no differences here. Again, this is a full fidelity conversion of the YAML program into Python. And what does that look like? Inside as Python, of course, we have some of the extra directories that Python has created. We have a virtual environment. We have a main.py, which is where our Pulumi program now lives. And inside, we have our same resource declarations, but now converted to Python, including, as you can see, handling things like this apply in order to be able to get the website endpoint and then interpolate it into a string. So you can see here where there are some advantages of YAML, where we've actually shaved away some of the complexity. But when you do need to go to a Python or a TypeScript, we do support that as well. And just to demo that TypeScript support, I'm going to now convert that to TypeScript. And we will shortly see a TypeScript version of our program. Again, installing dependencies, we're invoking NPM here, and we're going to pull down everything you need in order to be able to run a Pulumi up in that project, as if you had originally written this in TypeScript. Fantastic. And now we have the same program again now in TypeScript using TypeScript syntax formatted and using our Pulumi.interpolate syntax there. Thank you so much for your time today. And thank you, Kat. Back to you.
Thank you for that demo, Friel. And for those of you interested in the JVM, we are excited to announce support for Java 11 and higher, including languages like Scala, Kotlin, Clojure, Groovy, whatever. You'll get the same support for Pulumi's core features that you enjoy using any of our other supported languages, plus the feature-rich ecosystem of the JVM that you're already used to. That means the ability to use any number of JVM languages, all of the autocomplete and error support you get from your favorite IDEs, testing frameworks, and more. Now for your infrastructure, not just your application code. We'll soon also be introducing Java support for the Pulumi Automation API, policy as code, and multi-language component authoring. This is a huge step for our mission to make infrastructure as code accessible to all flavors of developers, and a huge boon for JVM developers who want to be able to manage their infrastructure programmatically without learning a DSL. Ready to see it in action? I would like to introduce to you Kyle Dixler, who's here to show off some of our favorite use cases for Pulumi in Java. Take it away, Kyle.
Hi, I'm Kyle. I'm a developer on the Pulumi Java project, and I'm here today to show off two stacks that deploy. One of them deploys an EKS cluster, which is Amazon managed Kubernetes, and an S3 bucket that's able to be accessed by that cluster through role-based access control. The other stack I'm demoing is going to be a Java Spring application that you're going to be able to deploy to that cluster using Java itself. So a lot of the Java devs out there that are really happy about using Java and might want to be able to use Java for more than just their application code, don't have to write YAML or a configuration language in order to do it. So the first stack that I'm going to show today is going to be that Kubernetes stack. This is more of a stack that an operations team would be working on. And first, I'm going to open up the build.gradle. In order to get started with this, you're going to want to, well, one, I'd recommend just copying the build.gradle itself because it's set up properly and it has the dependencies you need. So if you have com.pulumi in order to be able to use the engine, and then you have whatever providers you want to use right here. So if you want to import an AWS provider, you would do com.pulumi and then AWS. If you want GCP, you'd put GCP here instead. Okay, so now that we've covered just kind of the setup stuff, I'm going to go right into the stack itself. So if you see here, we want to import Pulumi, com.pulumi, and then in our main function, we want to use this run method on that class to be able to call this function over here. This function takes a context object in order to be able to define exports and to be able to interact with your Pulumi config. So if you look here, we have support for IntelliSense. You can see like what methods are on this object, and you can kind of consume them. It's really, really nice. So down here you see we export from the stack the kube config and the bucket name that we're deploying, and because we want to be able to use this in our Spring Boot application stack to be able to deploy it to the Kubernetes cluster we're deploying here. So at the end of this function, you're going to want to return the context.exports call and or the context.exports return value. And now that we've kind of covered this, this function, we want to move into the stack that's deploying this. So if we look, or the function that's deploying this. So if you look in here, we've got pretty basic setup. You want to create a bucket by calling the constructor, and you want to create a policy to read from that bucket by calling the constructor for this policy. They're imported through this through normal Java imports. You see the policies pulled in through the IAM wildcard, and you pull in the bucket through this S3 import. And one thing you'll notice is that we have overrides to be able to, or overloads to be able to, call it with just the name, and then it constructs it with the default arguments, or you want to pass in the arguments that you want to configure your resource with. So for the policy, we want to configure what the policy actually is. So we have this policy function on here to set it on the builder. So if you look over here, we grab the bucket name and we grab the bucket name over here and we inline it over here. There are probably you probably want to do some parameter checking on this if you do this yourself, but for the sake of this demo, we wanted to leave it pretty concise. So we have some helper functions down here to return the name of the bucket and also the read policy, because we want to be able to use that later on in order for our EKS cluster to be able to read from this bucket. So the next part is going to be deploying the EKS cluster. So we use our EKS provider to do this. So if you look in here, we have a cluster that we're declaring. So you'll notice that this has three arguments. You have the name, you have the arguments for this cluster, and you have this resource options builder. And you'll notice that we set protect to be true. We don't want to accidentally delete this for our demo because it takes a really long time to spin these things back up. And one thing I'd like to mention is that you get the nice rich IntelliSense that everyone loves about Java and IntelliJ, to be able to like get type information of what you can configure and what you can put in there. So there's that. And in order to build this cluster, we need to get information about the VPC ID and the subnet IDs. So we have some functions up here on this EC2 functions class that can get that for you. So if you see here, we call this get VPC method, and then we pass it some parameters, and then it gives us the VPC ID as an output. You can see IntelliJ tells us it's an output string. So another cool thing is that EC2 functions, you can see all the functions you have at your disposal through IntelliSense, which is really nice. I think that the getAMI one will probably be the most useful one to most people. But so you have other methods or other data source methods that you can access. For example, since we're pulling in the IAM import, we can actually check what IAM functions are here. You can see that a lot of these things would be kind of a pain to look up in documentation or right here at your fingertips, and including some of the documentation ourselves that we put in here ourselves. Now, the documentation that we have is in Markdown, and JavaDoc takes HTML, so we still need to format that a little more nicely, but hence this is preview, and I am writing this in pre-preview. So if the things look a little bit, if things look a little unpolished, it's just going to get better. So, all right, we deploy our cluster over here, and then we want to attach the roles that we passed in through the arguments, classic Java stuff. And we attach the role to be able to read from the bucket to the cluster. So now when someone deploys an application to this cluster, they will be able to read from that bucket. So now that we've kind of covered this stack, you'd probably, oh, right, I should mention, we have some helper functions over here to get the kubeconfig. And we have a function over here. Try not to look at it too much, it might hurt your eyes. But working with YAML and JSON inside of Java is not necessarily my strong suit, but I'm sure that there are a bunch of very seasoned Java developers out there that have ways of working with this easily. So we export these from our stack, and then we export the bucket name from our stack as well. And let me just run a Pulumi up. I've already run this ahead of time because, like I said, the cluster takes a very long time to spin up. Also note that we marked the kubeconfig as secret because there is a certificate in there and we don't want to leak that on the screen. So I'll put this, so it says the cluster is ready. It's running this stack. Should be good to go. While this is running, I will go into the other stack that I wanted to show off. Oh, it looks like it finished. You can see the kubeconfig is output here, bucket name is output here. Now let's look into the other stack that I want to use. So as you'll know, so this is a Spring Boot application. So if you look here, we have a REST control, we have our controllers, and we want to build it and deploy it to a cloud provider. So what I'm going to do is I'm just going to run, so we want to run repackage and build this as a WAR, and we want to run Pulumi up on it. So I'm going to run these now in order to, because it takes a little bit of time. So it's running the test suite that you guys probably, normal Java devs would probably put together, and it's making sure that it's sane. And it's going to put together the WAR file and start Pulumi up. So while that's going on, let me show off the stack. In here, we see the familiar Pulumi run, the imports we had before, and the Pulumi stack. Now we actually use this context object here to get the config, and then we are going to use this cluster stack reference parameter that we have in our config in order to be able to reference the stack we just deployed. Now, if you notice here, there's 2 stack references. While working on this, I found a little bug during pre-preview, and it's fixed now. But so just disregard this line. So if you look here, we get the output of bucket. We get the bucket name and the kube config, and we save them to variables. And then we passed in the jar path, which is going to point to this this WAR file over here, and to specify to this jar deployment that that's what we want to put on the put in the S3 bucket. So if you notice here, this is not args. This is actually a function that passes in an args builder. So one of the cool things about Java is do not repeat yourself. So if you know what this is going to take, you can have it take a function that gives you what it knows it's going to take, and then you can configure it yourself. So in here we have this builder that's able to configure it properly. Now, so might as well show off the deployment args. And if you'll notice here, we use Lombok. So Lombok's this nice annotations library that adds a lot of really boilerplate stuff with just annotations. And there's a lot of people that like it, and some people that maybe some people that might not use it themselves, but it's there. And I just wanted to show off that you can, in fact, use it for your Pulumi stacks. So now that we've shown off configuring the arguments, I'll step into this jar deployment. So if you look here, we are inheriting from this component resource, and we call super in order to set it up. We get the arguments, and then we're going to deploy that jar to the S3 bucket we got in. So if you look here, we create a file asset with a file path, and then we upload the jar to S3. Now you're probably wondering why we want to do that. So for running this demo, I didn't want to have to put together a Docker file because that's not Java. So I instead had it so that we have an init container that pulls down the application from the S3 bucket and then mounts it to a volume, and then the Java or the OpenJDK runs that jar from that mounted volume. So you don't have to. So it's very fast. You don't have to worry too much about Docker, at least in this demo. Maybe you want to use it yourself because there's obviously benefits for having saved artifacts, but really it's really up to you. So we pass in this custom resources option. We tell it that the parent of this resource is this component, the custom resource, and then we return the jar that we just uploaded. So the next part is going to be deploying the application to Kubernetes. So we pass in the kube config that we got from our other stack and the bucket object that we just deployed, and we go in here, and first we create the resource options that has the Kubernetes provider set up so that it can control that cluster. So it sets it up in here. If you look here, we add the kube config into this provider args, and then we also set the parent to this so that all of the resources are attached to it. And then we go down here and we're going to create a namespace. So we want to build a namespace. We want to create a namespace and then pass the cluster resource options to tell it that this is the cluster we want to create the namespace in. So down here, we have created our app labels. We create our metadata builder, And then down here, you'll see the deployment. Now this deployment can look scary at first, but if you've deployed something in Kubernetes, you know that this is kind of how Kubernetes, represents their stuff. It's basically a tree document structure. So the YAML is pretty much like a little bit one-to-one. One of the nicer parts though, is that we do get completion. So if you don't know exactly what's supposed to go here, it'll tell you that you can't put something somewhere, and it makes it a little more comfortable, a little safer, more comfortable to use instead of trying to navigate blindly in the dark about what the value is supposed to be. Now, one thing to note is that we have type safety, but one of the problems that you still have is that your strings, you have type safety, you know it's a string, but you don't know that the format of the string is correct. So if you've noticed, this is a huge blob of code over here. This is like a lot of lines. So you could actually split this out into your own function with parameters and then add some asserts or checks to make sure that the parameters are sane. So if you run into a problem where a value is getting passed in that shouldn't get passed in, you can catch it ahead of time and save yourself like a night of debugging to find that one of the parameters you're passing in is not, it has a slash in it and slashes aren't allowed, and Kubernetes just complains about that. So in order to accomplish the thing that I mentioned earlier with grabbing the jar from S3, we have created a volume over here. We've configured it with the basic options for empty directories, and we are going to mount it to this init container and have this init container use the AWS CLI Docker image, and then pull this asset from S3 into this volume. Then we have this Java container that mounts that volume right here, and then it runs it over here, which is pretty cool. We expose the port over here to 8080, and then we have a service over here that will make it available for you to use. Now that this is done, since this is finished building already, I will run the supply function, and hopefully it should work out. Let me full screen this a little more so it's a little prettier. So this code will also output an endpoint from it, so that we can just kind of go navigate to that endpoint, and it's more convenient. This might take like 30 seconds to a minute. So while this is deploying, I guess I can open up the Pulumi Java repo. And if you look here, you can see that we have some templates available. Oops. Yeah, so we have some templates available, AWS Java, Azure Java, GCP Java, and so you can be able to run Pulumi new and be able to use these templates. Another cool example I have is running a Groovy program, or a Groovy Pulumi program, because like Kat mentioned, we do support the JVM. So, a lot of people might have a little bit of fun seeing what they can run on there. So if we look here, this thing is finally finished deploying, and we're going to navigate to it. So I have to put a slash here because I use HTTPS everywhere. And if we go here, we should see that the connection was reset. And if you look here, we can see that our app was now deployed. So see, since we know, so definitely works, because we saw that, we saw an error message that was very dynamic. All right, and that's pretty much my demo. So tell us what you think about how our library is set up. Tell us what you like, what you don't, what could be better, and it will help us be able to steer the direction of this framework. All right, and back to you, Kat.
Thanks for that, Kyle. And thank you everyone for joining us for this introduction to Pulumi support for YAML and Java. We're really excited for this launch, and we hope that you are too. Code examples for all Pulumi packages now include sample code for YAML and Java, as do our getting started guides. So take them for a spin and let us know what you think. Enjoy the rest of Pulumi up.